Of this session is Lozano from here, IMPA, and he's going to talk about the effects of capillarity diffusion on non-strictly hyperbolic system of conservation laws.
Thank you. First, I want to thanks to Dan for giving me this work and the support with this year that he stayed in Brazil. This is part of my doctoral thesis. I can talk about this. The model assumption, we have a one-dimension original flow, three-phase flow, incompressibility and miscibility in the phase, no mass transfer among the phases, quadratic color permeabilities, Darcy law, and we consider capillary pressure effects, which normally is neglected, but in my work is a relevant role in the solutions. Some people to tell about this model in this meeting is the three-phase flow, fractional flow with quadratic permeabilities, and considered in the saturation triangle. And we are interested to study the Riemann problem that you use initial condition with left state and constant left state and right state in the beginning. The solution that we consider are shocks, rarefaction, or a sequence of them. They show that this continuous solution. We consider the Rakin-Hugonot condition. Sigma is the speed of the velocity of the shock, and rarefaction that are continuous solutions. Okay. We are interested to study to solve problem, consider physically correctly solutions, and for this you need to adopt a criteria of admissibility. We use a viscous profile. We study the traveling solution of this parabolic PDE, and if you substitute in the expression, you obtain this ODE, and with the conditions that satisfy the condition 9. We say that we have an admissible shock between left state and right state if you have an orbit connecting both. If you fix a left state and a sigma, we have a ODE with the vector field. Here, I suppose that the matrix B is not singular, but I thought about this in the next. Most of the work of this use viscosity matrix equal to identity. This is very good if you want to study proof theorems and mathematical analysis. It's more easy. It's not easy, but it's more easy to study this. And we first, in the beginning of my work, I consider a perturbation of the identity with a constant matrix, but after we consider a more realistic matrix that you can study that the physically correctly, that's the V matrix, depend of the point of the state. The difficulty to study this is the ODE system or the viscous profile is for this matrix, the Q matrix is not singular in the boundary. In the interior, you don't have the problem, but in this, you you need to study with more care. If you have a connection between repeller saddle, you have slow shocks. Between saddle attractor is a classical lag shock, fast shock. And between saddle-saddle connections is transitional shock that is not classical, is not lag shock. And you also consider sonic shocks that is as are limits of case shocks. Okay. This is a saturation triangle. The umbilic point is in the region 2 of the Schaeffer-Cherry classification. And I draw the separatrice OV, GD, AW. And if you consider the matrix, the viscosity matrix equal to identity, the only admissible non-lag shocks arise as heteroclinic orbits lying on the separatrice. If you consider a state over the line GD, the transitional shock is only over the same line. In this case, I draw to saddle-saddle, the U minus and U plus. The connections is a line, a straight line, if the connection is over here. But the question is, what happens when you use other matrix when in the viscosity? What is the effect of this? In my work, I have this. Is we call windmill. This is a transitional region, and the region do have connection between saddles, but it's not all the picture is in between regions. The red dark and red clear, light color and dark color with light color. The direction is important because the domains is for this color is here, and the codomain is here in this place, and the green color is in down way. We have a transitional map between the points in the interior, such as we have a point in the interior, and you have a transitional shock between the two states. In the same way, we have with the other points, and I want to clarify that for the green region, the region not touch. I have to a space is not in the umbilic point. The reason is the umbilic point is in the second region of the Cherry-Schaeffer classification. Well, what about the corners? The corners, for example, the A1 is in the slow boundary extension of the WOH of the triangle. That the condition is this, but it's a sonic shock between the A1 and A1. But you have two admissible shock. It's the same with the others points, B1 and C1. What about the other corner? The other corner is a point of the fast boundary extension of the WO, for example, and you have the conditions. It's a sonic shock between the point A2 and A2 in the boundary, and the same for the other points, the other boundaries. And this one is more difficult because we need to know that what is the form of the fast double contact, that you have a double sonic shock in the two characteristics velocities equal to shock velocity, and this point is on one point of the double contact is on the boundary, the windmill region. The same for the other, but for the green region, don't have point to touch the boundary, the fast double contact. Okay. In this picture, I draw the vector field for a fixed UL and a left state and fixed as sigma. We see that if you consider the same vector field and you change the viscosity matrix, for example, this shock is admissible in this case, but when you change the matrix, it's not admissible. This is a sensibility of the viscosity matrix, because this you need to construction of the Riemann problems, the Riemann solutions consider the admissible shocks. Clear to the rarefactions are not considered the admissible shocks because it's a continuous solution only to the shocks. In this picture I studied the solution, the Riemann problem for the left state here and right state, the same points, left and right, in the pictures. But the construction of the Riemann solution, in this case, we use, with the viscosity matrix, you use the rarefaction between UL and UA1. Then you use a sonic shock, this point, a slow sonic shock. This point, UN2 and UN3, is over the separatrice. It's a transitional shock that you need to jump here. You need to pass for this. This is a transitional shock, and then you use a fast shock between UN3 and UR. Now, if you change the matrix, the construction change. You do not need to transitional shock. In this case, you need, but because the shock, excuse me, first, we see that the UN1 and UN2 is not the same. It's other intermediate points. And you don't use a transitional shock because when you change the matrix, the transitional shock over the separatrice is not admissible. And for this, you need to change the solution in the construction of the Riemann problem. But what is the use of the windmill region? Más o menos así, no sé. It's a very bad picture, but it's depend of you put the UL. You use only a wind of the windmill. If you put the solution, the point, the left state here, you use the red one. If you put here, you use the blue one. And if you put here, you use the red one. This is with this in mind, you need to construct the Riemann solution for all the saturation triangle. This is my part of my presentation. Thanks.
Any questions or comments? I have one. Tell me something. This the windmill changed when you change the viscosity matrix.
Yeah. We have two things. First, if you change the point, the umbilic point, change. For example, if you have a umbilic point over this line, symmetric line, when you consider mu W igual a mu G, and this is the viscosity of the water, viscosity of the gas, the oil, no, the gas, sorry. The windmill is symmetric. In this picture, you see that this wind is different to the form, no? But if you consider the same, it's symmetric. But if you use other matrix, for example, constant perturbation of the identity, the windmill is depend of the matrix what you use. For example, if you use 0.2 and I don't know, the is more small, for example. Yeah, it depends. But when you use general matrix, the form is this one. Well, if you consider an umbilic point in the one region of the Church classification, the green wine is in the umbilic point, touch. But in this case, not.
It's not touching.
Not touch. The green wine.
In your experiments, do you ever have any example where you cannot find a Riemann solution or something
No.
well and you are
In all the
always works?
in those words, we need to consider where is the boundary that the wave curves cross the windmill, but you get a Riemann solution or the saturation triangle.
So this is, well, engineers like if they do capillary pressure for three-phase systems, they like to say that the oil minus the water pressure is only dependent on the water saturation, and then oil and the gas only on the gas saturation, and everything is in between. And I understand that the choice of capillary pressure model is affecting your windmill. Why am I mistaken? So, what model did you use for capillary pressure?
What is
What model did you use for three-phase capillary pressure?
We use the function of the capillarity in the P matrix, P tube matrix that depend of the water and gas, but it's approximation. It's a function that you use in some papers. Use a some approximation of the real pressure that, for example, Ismael showed the function, the pain of the saturations only, the water saturation, and we suppose that the pressure in between oil and gas depend on only of the gas. For example, it's a approximation for this. Yeah.
It has the right sign.
Okay, yeah. The question is, of course, does it matter? Yeah.
Huh?
Does it give different results if you're using different models of capillary pressure? That's
Probably. Yes. So in fact, we would like to get some advice from you on this.
well, I must admit that there's that the models which are that they say that the oil minus the water pressure is only a function of the water saturation is also hand waving and it's not necessarily physically based or whatever, and even needs to be consistencies.
Oh, but at least you can blame someone else.
Yeah, oh yeah. I've never blamed myself. So.
We should talk about formulas here, please.
But that was the joke of this disease which was in England. It's called
Okay.
PSE, and it's called blame somebody else.
Thanks.
Don't we use references in science for this purpose?
Yeah. Okay, but it's an interesting story.
Thanks.